Why are only the odd numbered nuclei fissile? Why aren't there any even numbered nuclei fissile? What does that mean? What that question means is if I look at the number of neutrons and protons in a nucleus, only odd combinations turn out to be fissile. That's a great observation and a great question. And probably the cheapest quality book that I found that describes that is The Chart of the Nuclides. If you were to get this booklet, it describes it fairly well. And it comes down to all of the interaction processes that are taking place. One of the jokes I like to make with my students is that all other engineering disciplines, you juggle valence electrons, right? For mechanical, chemical, civil, you're just controlling valence electrons in atoms. But in nuclear engineering, we also have to do the valence nucleons as well. And this is a great example of where that takes place. So all the physics that's there, that's present with regular chemistry in terms of the electrons and their orbitals, the Schrodinger equation, conservation laws, and so forth, all those are also present in the nucleus, so that you have different energy levels with the electron orbitals. You have different energy levels in the nucleus. And you have electrons that want to be paired up to make a Lewis structure, to do bonding. The nucleons in the nucleus also want to do that. They also want to be paired up. So when you have odd numbered ones, they don't have something that's paired. So they don't have that extra binding energy that comes with being paired. And that's what occurs when you have even numbered nuclei. They're able to be paired up. Now, in principle, the neutrons are going to want to pair with the neutrons and the protons with the protons. But the point is that I do get differences in energy levels if I have that pairing. Now, there's a lot of other physics that's taking place because you got the Coulomb repulsion that's there, you got the strong nuclear force that's there, you have the uncertainty principle, you got massive energy that's there. But that one feature, that pairing, is actually observed when you see something like that. And there are other places you see it too, in terms of, say, energies for alpha emission from the radon progeny and so forth. There's a lot of places that you see that, and it just comes down to the basic physics that you also have in the atomic model, that's also in the nuclear model. It's just you got a lot more physics there as well. So, great question.